Alright guys, so I just wanted to do a video to show you, for you to have a reference, if you are doing correlation and linear regression, you're going to have your data set. So here I've got age versus state income tax paid, and we want to find, is there a correlation between these two sets of quantitative data. So the first thing I'm going to do is I'm just going to highlight both sets of data. I'm going to go to Insert, and I'm going to find the thing that looks like a scatter plot. Okay, and if your scatter plot's too small, you can grab a corner. See how you get this funny looking double arrow here. Okay, so if you get this arrow here, you can move, well, oops, if I grab it right, you can move your scatter plot. And if you get this arrow here, you can make your scatter plot bigger. Okay, so here's our scatter plot, and we see it's kind of an upward trend. It sort of looks like a line. So we think there should be fairly positive correlation. Also, make sure you do realize it is an upward slope, so it is a positive correlation. So I'm going to click on these dots. So see all these dots here. I'm going to right click. And when you right click, so it's the right button of your mouse, go to add trend line. You get this menu pops up over here. Okay, and all you got to do is click display equation, display R squared value, and then X that out. Okay, now when I do that, I'm going to get something that looks like this. Okay, and it's kind of small, but and I can drag it over here and move it. Okay, I can also make the font bigger. Okay, I'm going to make that bigger just so you guys can see it in the Excel video here. So I've got my equation and I've got my R squared value. Now you have two options. You can take the square root of this R squared value, or you can come over here and use the Correl command. So equals Correl, and you're going to type both sets of data in. So I'm going to say parentheses A2 colon A15. And make sure that it highlights all of that data in that age column. Then put a comma, B2 colon B15. And you're going to highlight all the data in the second column, state income tax paid. And what we see is our trend line has a correlation coefficient of 0.79103. You can also find this by taking the square root, SQRT, of the R squared value here, 0.6257, 0.6257, and you get basically the same number, 0.791. Notice it's slightly different as you get out to the end decimal places, and that's because this guy over here is rounded, and this one using the Correl command is not. So anyway, there we go, folks. So there's your correlation coefficient. Now what you would do is you would go to your critical values table that I handed out in class, and you would see for this number of data, well, how many data points do I have? Well, it starts at A2 and it goes to A15, so that's 14 data points. You can count these up. For 14 data points, what should the correlation coefficient be for 95%? Okay, so 95% confidence. And if this number is higher than what is on your table, you can use this equation, this linear model, to predict what someone would pay later on or at a certain age. Okay, and if it is lower, then we say it is poorly correlated, and you would not use that model to make any predictions. So anyway, thought that would help you guys. Hope you enjoy it, and if you have any questions, let me know.